Still up here. Okay.
Hello and welcome to the Technology, Risk and Gambling Seminar Series. I'm really excited about this episode. It's someone I've been wanting to chat with for a while that we've met through mutual connections. So a big shout out to Khalil, the co-host of this seminar series, for the introduction. So I'm very excited. Dr. Frederike Petzschner, who is an assistant professor at Brown University from the Carney Institute of Brain Science and the co-director of the Brainstorm program. That's a lot to unpack, which is why I am starting this season by having my guests introduce themselves. Ricky, it would be great if you could tell us a little bit about yourself and your current roles.
Yeah, very happy to. Nice to meet you, Sally. And finally, it's working out. I'm quite happy about the conversation. So I have a background in physics. Basically, I did all the way to my master's thesis. I didn't even really think about neuroscience or that's a field of research that exists. And then at the very end of my kind of studies, I had to give a talk about how you can build neurons out of transistors. And I realized there's this whole world of neuroscience, and I wanted to do a PhD. So I moved into neuroscience, and I first did do nothing with gambling. I studied how we perceive space and time in humans and how you can use computational models to unpack that and look at how we make errors and how we navigate space. And that was my entire PhD. And then I did a postdoc, and I was talking to someone at the ETH Zurich, and he was very interested in mental health and said, we look for people who can do modeling and understand something about perception, and we want to apply it to diseases. And that's really how I got into this whole space of understanding well-being and understanding risk-taking in kind of a healthy context, but also in the context of disease. And one of the projects that they were interested in doing was on disordered gambling. So that's really how I moved into a field that's now called computational psychiatry. So you look at human behavior, you look at brain activity, you try to understand what is it that the brain is doing during those processes, and can you measure that, can you quantify it, and can you understand how it relates to symptoms. And so for the longest time now, I've been working in the field of computational psychiatry. But because, we're not just the actual kind of computation without the surroundings, I realized that a lot of the specifically mental conditions, it is about emotions, it's about how we feel, and not just about how we rationally think about things. And so I wanted to introduce the body back into our models. So try to understand what are the signals that are coming from the body, how do they affect the way we process information. And there's another area which is called interoception research. So really it's studying body-brain interactions. How do bodily signals give rise to emotions? How do emotions affect the way we regulate our bodies? How can that lead to symptoms? And so now I'm doing a lot of modeling that involves the body as well as the brain. And yeah, so that's what we've been doing up until I moved to Brown University. And now we're really interested in studying these interactions in different contexts, in addiction, but also in context of chronic pain, actually. And there we've been doing quite some interesting projects over the past couple of years.
Yeah. That's so interesting, and there's a lot to unpack here. And I think many people who are regular viewers of the show will not be familiar. And I confess I'm not overly familiar with computational psychiatry. Traditionally, I'm a psychologist, so traditionally we have approached thinking about certainly the brain body together and the environment, and not being as separate as a medical stance might be. And I work with a lot of economists who think very much around, decision making and what are the inputs and stimuli that impact decision making. But explain to me a little bit more around the computational side. I think is sort of the modeling side. So how do you cross different fields? You've got a physics background, which again throws another whole sort of modeling aspect in there. So what are you working with? Are you working with brain scan imaging? Are you working, you know, as a psychologist, we often work with surveys. Economists look a lot at, you know, behavioral data. What are you bringing together, and what are your sort of outputs? How does this all, you know, come together? What are you modeling exactly?
Yeah, good question. And it's actually not, it's not always the same thing. So we've been doing neuroimaging using brain scans. We've used EEG data, but a lot of what we do is actually develop games. So not really questionnaire data, but you develop a little game that someone plays and you measure behavior. And for instance, very simple cases, you look at how do people learn in different contexts. Like we have a context learning task where in one case you can win rewards and sometimes it's more likely to win and others it's less likely. And in the opposite case, you try to avoid losses. And so these are very different environments. And for instance, in one case, the expected value of both actions is good, but one is a disappointing action if you didn't get the reward you were hoping to get. But in the other case, when you avoided the loss successfully, you still lost some money, but not as much as you could have. So it's a relief signal. So something that is a bad outcome in an even worse environment is something that might be paired with a positive surprise, as opposed to something that's technically good, but you were hoping for something better, is experienced as a negative prediction error. So we look at, now we can describe how you're learning from those encounters. And you can dissociate between overall, what's the expected value of things, is it good or bad? As opposed to, yeah, but how much is that actually driven by your own individual experiences over time? And the types of models you use there is, for instance, reinforcement learning. And so it really tells you something about kind of how you're updating your beliefs over time, and how that determines how you make choices, in, you know, in the game, but then also in real life. And then you look at what is the underlying neural architecture that is causing the decision making. We are very interested in one area, which is the prefrontal cortex, which is often, you know, learning more about context, and the striatum, where you think a lot about the classical reward processing and the dopamine system. And you basically try to infer what's the other underlying computations taking place in this network in participants. So that's one form of modeling, yeah, that we do.
Okay, that's really interesting. So that seems a little bit around similar to sort of what economics do,
Yeah.
but when you've got the, you know, when you're talking about mental health, obviously that brings in the individual differences, so that there'll be different people who will react differently to stimuli, and then also in different contexts as well. So I'm thinking of some of the experiments in the gambling field where we've used simulated gambling environments, which is similar to what you're describing, I think, a game. How does this these experiences and this modeling translate to real world? You know, how do you know if what happens in a lab in a simulation is the same as what's happening in a more complex environment?
Yeah. Well, I can tell you at a high level and then kind of very concretely in the context of gambling what we're seeing. So at a high level, what people have looked at is to say, or is there anything we learned from a model that we couldn't have just learned from scanning your brain or asking you, you know, you using questionnaire-based assessments? And the way that's typically done is you use, for instance, a machine learning model. You say, can I predict symptom severity, or can I predict whether this is a patient and this is a control, based on either the model output or brain imaging or behavior? And it turns out that the model parameters outperform other measures, and that's been replicated many times now. And the idea is, why is that? Because technically it's describing something that should be in the data, but the idea is that models can distill down kind of the variables of interest, the actual process that is potentially leading to symptom development. So that's why they have become so successful, is because it's basically increasing signal to noise. You're trying to infer the underlying cause. In our case, what we've been doing in one of the studies we've been doing on gambling is we're two groups. One group are recreational gamblers, that basically just people who gamble for fun. It's a criterion that they have to gamble. Either it's roulette or it should be a casino game. It could also be like certain forms of lottery. but they have to have experience in gambling. And then the other group are individuals who have suffered from a gambling disorder and they're seeking treatment. So they're like at the beginning of therapy. And we basically also developed a game where they played on different slot machines. And we just looked at their bad behavior. We looked at how they predicted outcomes and learned about the probability structure of those games. And one of the interesting insights is the bad behavior you see on these artificial machines directly relates to symptom severity. So you can basically predict symptom severity just based on this game-like behavior, to the extent that we've really seen a kind of quite strong effects between the groups, but also among individuals, and like, you know, looking at the granularity. And then what we've done is we manipulated features of those slot machines in a 2x2 factorial design. So basically we're trying to figure out, how does reward magnitude influence the way you bet? How do beliefs about control influence the way you bet? And that's the data set. It's been quite exciting to look at lately.
Awesome. And I'm really keen to sort of unpack that a little bit more, but I want to get a bit more background first to make sure I understand it. So from what I can, from then what you're saying is that what you see in the simulation does map onto their problem gambling severity, suggesting that what they're doing is a good replica of what they're doing in the actual gambling venue, because you see these same behavioral differences. Do you think these are then something that these individuals had pre-existing differences, or are these differences a result or a change in them? And is it a structural, like, neural change? Is it, you know, we know with there is some studies that suggest there are changes in neural, the differences rather, in the neural structures and pathways of people who gamble in a problematic way compared to those who don't. Similar, we see this in other addictive behaviors, but obviously there's substances involved there, so it's a little bit it's quite different. So are these individuals who had pre-existing neurochemical or neurostructural changes, or are these changes that occur as a result of gambling excessively or problematically?
Yeah, it's a very good question, and one that's like, in this study we cannot answer if it was there prior, basically, if it was a risk factor that led to an addiction, or if it is a consequence of the addiction. When we're talking about kind of, are there neurobiological changes? Is there like changes in the underlying physiology? I'm very much on the side that I think everything we say, do, think has an underlying neurobiological origin. So even, you know, we study psychosomatic symptoms and people say, oh, you know, if a symptom is all in my head, is it not real? And I think that's a completely wrong way of understanding it. There are biological changes, they're just at the level of your brain and maybe not in your foot. But they have physiological consequences in the way that we regulate our bodies. They have consequences on the way we make choices. So everybody has basically a different underlying neurobiology that's giving rise to the way, the symptoms we develop, the behaviors that we show. One interesting example of that, maybe is a small tangent, is the placebo effect. Well, placebo, everybody kind of knows that when you're taking a pill that has no active ingredient, but you believe it's going to help your pain, in the placebo analgesia, you'll have less pain, and most people will have a placebo response, specifically if you prime it right. And so everybody thought, oh, that's an imagined pain reduction. But actually now people have shown that the placebo, the belief, activates your endogenous opioid system. So there's, in your body, there's opioid release similar to the way you would get it if you're taking a pain medication. So that's why I'm thinking in so many cases, your belief systems are what's usually regulating the entire body. That way, kind of hard to distinguish, like, anything we experience, for me, the way I think about it, has this like neurobiological origin. When it comes to risk factors, so I couldn't tell you if there was a change prior and that led to the behavior, like, you know, in this case, a behavioral addiction. But what we've been looking at is we actually followed people up over time while they go through therapy. So now you can do, like, longitudinal studies allow you to actually try to say what's cause, what's consequence to a certain extent. And we have data from the same group of participants 3 months later and looked at what predicts whether you're benefiting from therapy. And with the way we do this is we take a subset of the people, we train a model to predict out of samples. In a separate sample, we test how good our model is. And we said, what is a predictor of treatment success? And one of the things we see there is actually that higher levels of anxiety are a really bad predictor for outcome, which we didn't expect, to be honest. You see that therapy has a lot of positive consequences for individuals. So both their gambling symptoms go down, but even more interesting, comorbid depression is improving a lot. So while depression improves significantly due to cognitive therapy, we didn't see that change in anxiety. And we wonder if those individuals who have high anxious traits have a harder time benefiting from the therapy and therefore have worse outcomes. So that's something to kind of look into more deeply to understand better what's going on there. So yeah.
And I think that makes so much sense that, and as we know more about the mind and the body, that it's not so much what's real and not real. If someone is feeling less pain, they're feeling less pain, you know, that's and I think it's really interesting when you were talking about the different reactions as well, because one thing I find really shifts people's thinking about gambling is when I describe some of the neuroimaging studies in the field by people like Spencer Murch and Luke Clark that show and similar, building on Kevin Harrigan and Mike Dixon's work on losses disguised as wins, that for someone who is potentially gambling in a problematic way, their experience of a loss is very similar to their experience of a win, because they view the loss as meaning they're closer to getting a win, from this irrational belief that you know, there's a linear series of outcomes on a game that is chance-based. So it's an erroneous belief. But if you believe that it's a linear relation and you see the loss, you're saying, actually, now I'm closer, that the win must be closer because I've just had a loss. You know, I must be making progress, which is not accurate, but it's really interesting. And when you can put yourself into that person's mindset, you can understand then why people continue in the face of losses, because I think that's often someone that's not interested in gambling or doesn't engage in the behavior. They keep thinking, oh, why wouldn't they just, you know, walk away? And certainly, you know, when I was first heard about this field, that was something I thought, oh, well, why would you just keep spending money if you keep losing? Surely you would learn and then understand that it, you know, the way that someone thinks about it makes the behavior not logical. So it's not appropriate to use terms like responsible gambling, because you have to understand where that person is coming from. And so you're layering onto it of the neuropsychology and the neurocomputational psychology is really interesting. And maybe you can respond to this kind of challenge that I've heard raised of, you know, what's the point of scanning people's brains? Because, you know, what are the practical implications? We're not going to set up scanners and put everyone through an fMRI and say, okay, well, you can go into the casino, but no, you've got a vulnerability. But I think what we're increasingly learning is through these understandings, we can then look at what's happening in a simulation. But really critically, we can do things that we can't. We can't set up a casino with different features on it and say, okay, well, this is having that reaction, this is having that reaction. And what the field's really lacked is research on the structural characteristics of gaming. And that's something your research can inform. You know, what happens if the music is louder or the features are faster or slower? You know, you can experiment and tinker with a gaming environment in a way that would never be possible in a real world scenario. Is that one of the ways that you think about? You know, I guess I'm trying to get at, you know, that there's so what, and there's so many different ones, but what do you see as kind of the, you know, the outcomes of this body of research?
Yeah, I mean, I love what you just said. Like, I have so many thoughts. So the first one is, yes, I think you can basically control something you have a controlled environment where you can study the effects of like certain game features. And for a long time, I've been thinking, well, obviously the industry has studied that for a long time, and what we're often doing is reverse engineering. Things like, you know, when the game duration is shortened, that people not only play more games in the same amount of time, but they actually end up playing longer. Why is that? There's a lot of components, and if we learn to understand how they affect gameplay and why they affect it, you can really think about what is useful regulation and what's not. And also what are changes that are being implemented that are actually not beneficial for players. And so I agree, no, but the point is not to do diagnostics based on an fMRI scan. You don't need diagnostics based on an fMRI scan to determine whether someone is like suffering from an addiction or behavioral addiction in this case. A lot of what you can see, like actually some of whether someone might have a problem, you can infer from behavior, and these tasks allow us to say, well, are there particular features in the gameplay that point towards that? So you don't necessarily need a brain scan, but you can understand what are the circuits that are being involved, that are being targeted, that lead, for instance, also to compulsive behavior. And talking about the example that you gave, where I think it's absolutely fascinating, this idea that if you are in an environment where you have a near miss, and the near miss, like we see the same thing actually in EEG data, that the near miss seems to be processed like a win, not like a loss. So the signature looks much more like a win. Why is that? Well, we've evolutionary been living in a world where learning was meant for skill acquisition. We're all trying to learn something, like, acquire new skills. So when you're riding your bicycle for the first time and you have a fall, that's a teaching signal. And then the next time when you kind of navigate a little bit in the other direction and you almost made it, but not quite, that's an even more potent teaching signal. It's totally, you're getting there, but you're not quite there. So a near miss is nothing else but I think a teaching signal that's directional and saying, hey, you're getting better at whatever you're learning. And so I think they hijack a system that is the most like prominent system we've been using for every other skill we've learned in life. And everywhere else, usually when you spend a lot of time doing something and you get rewarded for your behavior and you sometimes make small mistakes, but you still get these directional indicators, we end up getting better and we acquired a skill. Now it is completely artificial to be in an environment where all of those signals are there, but it's chance and you're not actually getting better, or you're being signaled as that you're getting better. So I think, in my opinion, when I kind of moved into the field, I always thought gambling is about skill learning. There is something that you think you're learning, even though you cannot predict the outcome. But you're learning a ton. You're learning a ton about the machines. If you ask players, they know the variance of the machine, which is not on the machine itself. They can tell you that's a high variance, low variance machine. That's conversations that, where you realize, well, you actually are learning a lot about the outcome statistics. It just doesn't help you at predicting the next outcome. And when we designed this task, I wanted to get at exactly that this idea of, I think I'm in control because I'm learning, I'm getting better at this, is a driver of gambling behavior. And so the way we did that is we had the near misses, but we also introduced stop buttons on the machines. And the stop buttons would stop the wheels, but the outcome is pre-programmed, which is quite similar to actual machines where the outcome is drawn on such a high frequency that it's also not predictable. So, there were these times where people were trying to hijack the old machines, but nowadays it's pretty hard. So basically what we did then is just see, well, if there's stop buttons that allow you to execute an action, which gives you a sense, an illusion of control, does the illusion of control change the way you gamble? And the answer is yes. The effect is quite strikingly strong, where you actually see that they bet higher when you think you're in control, even though the control has nothing to do with the outcome. But then the question that I thought is, okay, why is it though? And in this modeling world, for the longest time, people thought, how do you determine what is control? And control is how likely can I achieve an outcome? So basically, if I can lift this mouse and 100% of time I'm doing this, it's actually lifted, I'm in control because my action led to this outcome. And that's the probability. And if it would only happen sometimes, I'm not fully in control. There's something else that determines what's happening. So basically, it should change your prediction of whether you can achieve an outcome that you want. In other words, it should change your prediction of winning if you think you're in control. Like my partner, for instance, he does parkour, and I see him do things where I think that's just risky. But he tells me, no, I've done this a million times. I know exactly where I'm going to land. Has nothing to do with risk anymore. This is all control. And over time, that's true in skill acquisition, right? Like something that we consider risky for someone else who has the skills is not risky. And so basically you start to predict that you will be better at something if you spend a lot of time on it. And that's exactly what we shift when we ask people to predict outcomes and they're in an environment where they have an illusion of control, no actual control. You see that they predict that the wins will be much higher. And so really what it does is this illusion of control changes the way you think about winning for you personally. And oftentimes, it's that, oh, people have completely distorted probability distributions of who's like whether you're winning or not. And I think that's actually not right. We all have distorted probability distribution when it comes to our own skills. If you're good at something, you predict that you will win more likely than your neighbor who has never done it, for instance. And I think that's what's happening is that with prolonged gameplay, there is these implicit beliefs that distort the probability distribution, but basically as a consequence of kind of skill learning. So that's tapping exactly into what you were saying earlier. And now we have, now the question is, what's the benefit of using a model? And the benefit of using a model is that I can actually now compare describing the behavior we see by someone who doesn't learn at all, or by someone who learns, and by someone who learns and their learning is described by changes in control. And you can compare what best describes behavior. And we see across the board, people are learning on tasks that are random. So that's where the modeling is really helpful, is because it gives you new insights into these intuitions that we had for a long time. And actually, you're now able to show people are learning, and here's how it's really affecting gameplay. So it was a long 10 minutes.
It's so interesting because you've tapped into so many different, I mean, I love that you bring biology, evolutionary biology into there just to, round off our ABC of the entire field of academic research. I guess my question then, and it's why it's really interesting, I love talking to people outside of disciplines because as a clinician, one of the things that's really consistent is people who come into treatment, and obviously that doesn't represent everyone that experiences gambling harm, it's only a small subset, but we really commonly find some early experience of a big win, which is big relative to the individual. So it's whatever it's a meaningful win for them, and often a very positive early experience. So when you initially started engaging in gambling, or at least when gambling, if when gambling became problematic, at some stage there was a really pleasant association, whether that was, a social or familial, like it was a relationship strength, or it was the win, so it was the monetary outcome, but there was something really positive about it. And so likely that's, the win and the positive experience is what's getting people from being an infrequent person who gambles to someone who actually engages this more regularly, which totally makes sense. We all do things that's more enjoyable and was positive for us. So that's not really a complicated explanation. But then my question is, for people who do start to gamble more frequently and enjoy it, and usually it does start as an enjoyable and continues for some people for quite a while as being enjoyable but manageable, what is it that is different for some people that they end up with the same product, same environment? Is it that they had a different experience? There was some kind of learning, so they saw someone win a jackpot, or they had some kind of learning experience that has encouraged an illusions of control, because the product is random. I started off not in the field, but I started off working in bars before I was in the field. I was working in hotels, and I would watch people while I was polishing glasses and earning, $15 an hour, play machines, and be thinking to myself, they've got $900 and they leave with nothing, and they come back and they're like, why don't they learn that it's random, that they lose off, like they lose more than they win? I mean, this is, I suppose they leave with less than they win more often, because you do have wins when you're playing machines, but you usually respend them. But why, what is it about some people seem to develop illusions of control and become, engage in problematic behavior, from the people who can continue to gamble but still have that understanding of its random? Or is it, which is also common, most people don't understand, you know, even people who play without problems probably have illusions of control and don't quite understand the machine. So I'm trying to get at, you know, is it an environmental difference? Is it a learning difference? Is it a neuro, you know, structural difference? Why is it some people end up gambling in a problematic manner and having more of these erroneous and irrational beliefs?
Yeah, I think that's the holy grail. Why not exactly? I think one point I think you probably think about it the same way. Oftentimes we put people into two boxes, which is you have gambling disorder or you don't. And with very few exceptions, there are some, you know, like psychosis or not, that's a difference in state. Rarely ever I see in mental health that it is really two categories. What I really end up seeing is there's heterogeneity and there's a spectrum, and you're somewhere on that spectrum. And then what we do is we draw a line somewhere and say that's no longer healthy and that's healthy. And that line also shifts over time. So what was considered, like we know that now, for instance, with what was it? I think it was blood pressure, if I'm not mistaken. And some physiological variable that used to be way lower in the 50s because people were actually having a healthier diet, and it's shifting upwards. So because the mean shifts, and we always relate things to the mean, people are actually doing much worse today, but you have to do way more in order to still consider it. Don't call me if it was blood pressure, it was some one of those variables, but it basically means where you draw the line is relative.
And what's accepted in society as well.
Yeah, absolutely. And so that's already the first tricky part, because that means we cannot say what makes one person of the group like that and the other, because we rather have to understand what's the gradient and kind of where is that gradient very unhealthy, like where does it become unhealthy, but also what explains the overall gradient. And everything I said earlier about the illusion of control and how it's affecting outcome predictions and bad behavior, we see it in both groups, not just one group, both recreational and pathological gamblers. So that's not the differentiating factor. Everybody is subject to illusions of control. I mean, we lived through a pandemic, and I don't know how many people became excessive hand washers for a short period of time, or washed surfaces where we now know it wasn't contaminated or like transmitted via surfaces. But because suddenly your belief changes, you end up showing behaviors that are compulsive. And because under your belief system, they're very rational, something you mentioned earlier, where I think that's actually very true. We have to understand oftentimes behaviors that appear to us irrational are not under someone else's belief system and an experience this individual made. But so then the question is, well, still, is this, why is someone reacting different to the same type of information? And as so often, I think it's a mixture of, there are risk factors that maybe, you know, this nature-nurture difference that you have from the get-go, that you might have like high levels of impulsivity. And yes, we see that. It's a, you know, it's a predictor, but also there's a lot of it as experience that you made throughout lifetime. Think of the big win at the beginning, which is a very unlikely event. Think of the positive relationship, like where clearly, I think in that sense, it's not so different from depression, for instance, where any major life event in depression, even positive ones, can be the onset of a depression, like childbirth or getting married. Changes kind of are affecting your experience in life that can be the trigger, so to say. So it's a mix what exactly it is and how to determine it, and if, you know, then how it, for instance, relates to the dopamine system, and if there's like from the get-go differences. I think these are all the big open questions. There's so little on actually looking specifically at dopamine, actually. And I mean, it's hard to measure, but there are ways. It's just very rare that we get that type of data set that we can actually look at it.
There's that, and I really like that idea that there's so many differences, and we can predict some, and there are natural differences that we accept in a population. And certainly I think anyone that's done Psych 101 and started learning about mental health disorders in any aspect has spent a good couple of hours secretly diagnosing themselves with every mental illness they learn about, and then quietly confessing it to someone who says, me too. And then we recognize this idea that it is a spectrum, and we all have aspects, and particularly something that I really try and put into my writing, because I think this gets confused, is yes, the gambling disorder is a behavioral addiction and it's a disorder, but it's not a trait. It's not a stable, you've got schizophrenia, it's sort of a medicalized condition, or you don't. It's a behavior. When we talk about problematic gambling, it's a behavior. You can be gambling problematically without having a gambling disorder. And these are, if we look at the behavior itself that's causing the problem and distinguish it certainly from the individual, is something that's really important. But and it's individuals as well. That some people will gamble problematically in one particular state of mind and not in another times, where we have different vulnerability periods. And I think these sorts of things are really important to discuss, because so often when we're talking about prevention, it's focused on the individual. And once they're a problem gambler, then we go and do all these sorts of things. But until that point, it's fine. They're not a problem gambler, so let them do whatever. No requirement on the venue. But I think that what you're talking about in terms of a spectrum is really critical to recognize that everyone has the potential to engage in problematic behavior. I guess it's more about the impact it has, which is then when it gets into more socio-policy, issues, which are a kind of a whole nother conversation. But where I want to come back to is this idea of, what do we do? And one of the things I really love about your area of work is the ability to do something which is being really neglected in gambling, which is understanding the characteristics of the environment and the product and what can be manipulated. You mentioned a stop button, and in several jurisdictions now, the stop button has been banned on devices because they are deliberately encouraging illusions of control. They have no effect whatsoever, but they deliberately encourage people who are playing the machine to think that they do have an effect, and it's just completely misleading. I think you could make, and in fact, Khalil and I have made several arguments around other factors of EGMs or slot machines, anything that has a pick and choose function, whether it's in a feature and you get to pick a device, and we're not necessarily saying that this should be banned, but that they can encourage illusions of control. So it's how much do we allow features that are entertaining and fun for the player that could be problematic outcomes? And I'm wondering what other structural characteristics you see across different gambling opportunities, whether it's online or casino or sports betting. Are there other kind of features that you look at through your lens and think, ooh, that's interesting, how people might interpret that? I wonder if you have some, on your list of, on your radar of things that could be highly influential for players, in terms of their behavior.
Yeah, there's actually, I think there's a ton. Let's get into a few. I think that what you were saying is completely right. Anything that is an action where it is portrayed as having an impact on the outcome, but in reality it has an impact like only for yourself, but not really on the thing you desire. Yeah, and it's not that a stop button does something, it stops something, but that's not what you care about. You care about whether you actually get a good outcome or not. And that's the part that it doesn't do, and that's what it's pretending to do. You have the lights on top of the machines that tell you it hasn't been played for a while. Again, there's the idea of, basically trying to signal that there's hot and cold machines. And
this
so
that's one recently.
Again, sorry?
Like this machine, the jackpot's been paid. This machine's recently paid a jackpot.
Yes, exactly. And the truth is it's random, so it doesn't matter. Like it really, like it's one of those, again, you provided with information that is supposed to be meaningful, but it's not. And so therefore it is used as an illusion of control. And then people think, oh, I need to, I figure out how that information can be used. But it is de facto not useful. There's what I think is interesting, because you see that mapped not only in gambling, but also in social media, is that there is no, usually when we engage in a behavior, we have to initiate the behavior. So, but on social media, the feed is infinite. So you have infinite scrolling. And that was one of the big things that made social media so much more addictive. So before you would see the information, and at the end of the screen, it's the end of the screen, stops. You have to actively choose to seek more information. The same with the machines. If you have the money in, they keep rolling, and but you basically there's no like thing that actually stops your behavior and gives it a hard cut, and you have to actually, like, for instance, constantly, like, unless you have to put money back into it, but it's made so easy that you can now sit for hours and just keep playing with very, very little effort. And basically the doom scrolling in social media, that's the
Netflix, infinite, automatic play, YouTube and
infinite
Netflix.
recommendations, which means that basically, and what it does is you never consciously, cognitively, you basically don't have to use your prefrontal cortex, in other words, you don't have to decide that I want to continue like doing this behavior, which is in a very unnatural situation to be into, is just to be flooded passively by it. So, things like that, where I think it was in German casinos where they force breaks now. After, I think, a half an hour, you have to have a 5-minute break after an hour. Those breaks are actually interesting in many ways, because it could be a moment that you leave, and specifically because you don't have a feeling of time. There's no watches in casinos, etc. So, like, you have very little control over time passing by, which is again on purpose. And in this case, I think it also serves another component for some individuals. I'm sure, like, not everybody, but gambling can be in very good and effective escape from a situation that you're in that is otherwise stressful, and not one that you like to be in, or one where, either out of boredom or out of other stressors in life, you want to be in a place where it feels like a lot of time is passing and I don't have to worry about the thing that I probably have to worry about. And so I think that is, we actually try to look at that also with a model. It's called opportunity cost. I'm like, so we can either have this conversation, or you could be cooking, in your case it's morning, so probably like breakfast right now, or like, see your family. And sometimes you say, well, is the thing that I'm doing rewarding enough to not disengage? And everybody knows that if they have a boring conversation, or if there's something that they don't want to be in, then they want to disengage, and our phones are always close by to allow us to disengage. So gambling, it's a similar thing. It actually allows you to be in a context for a while, and oftentimes you don't disengage because what's out there isn't as rewarding and as tempting. And for others, where like, and so basically you have this trade-off between opportunity cost. Many people disengage from something that I've been doing for a couple of hours, because now they feel like, I want to do something else. There's something else out there that's also interesting. You can try to describe that. So having breaks allows you to actively actually think about the opportunity cost of things anymore, which you don't do when you don't have, like, any stop indicators. So that's another one that was like a long one on features. The other one is duration of gameplay. I think it's a big one, where I think more and more why that is, and I don't have a good answer. I really don't understand it yet. There is an optimal duration for things that is most engaging and most reinforcing. And I don't know if it has to do with the preferred intermittent reinforcement schedule of humans, but we know that for video content on TikTok, it's between 8 and 12 minutes. We know that YouTube has, like, now introduced shorts, because there is this whole component. Instagram has introduced reels, 1 minute. Like, for different types of content, there's a certain lengths that people engage in the most with. And in the gamble, it was like the gambles got shorter and shorter and shorter, single gameplays. And I also wondered like, clearly something is happening there where they optimized for maximum prolonged game. and something that I feel is a bit understudied because we don't understand why.
I haven't seen much research on that at all. That's really interesting. And you're right, because I work at a university, and we have people trying to teach us, how do we teach students now who have the, attention span of like 7 minutes, and like you have to take a break every 7 minutes in your lecture, and this idea of people having attenuated to the ability to consume content. It used to be the advice was you have about 7 seconds to hook someone with, content. I was at a seminar last week where they said it's like 0.5 seconds now you have before someone, swipes and move on, which is, fairly difficult to, that's a whole nother conversation. But this idea of gambling being something that has been successfully, designed such that people will do it for hours and hours and hours and hours and hours, similar to, social media and Netflix and, sorry, not to streaming services, I'll say, that people do it, but they engage in different content without that break. And that the lack of natural break in play is so critical, because people aren't making what I would call a rational and informed decision. They're status quo doing what they decided to do at the beginning, but they haven't actually remade that decision, which is why something like a smoking ban, which forced people to get up and go outside to smoke, has a really good impact on revenue in casinos, because it actually allows people that break to go, oh, actually, yeah, I'm okay to do something else now. So it's been one of the most impactful gambling regulations was actually a smoking regulation. But I think that's really interesting, because as you were talking earlier, I was thinking it's really important to design products and environments so they don't have misleading features. That should just be part of consumer products, but apparently we have to specifically regulate it for it. But, this other idea of designing an environment such that consumers are actually prompted to keep making their decision or to keep confirming their decision. And it's similar to what we've seen in other fields. So now we have regulation that if you've signed up to a newsletter or a subscription service, you have to be contacted, say, once a year to reconfirm, yes, I still wanted to do this thing that I signed up for. But there is nothing in gambling that is, obviously once a year is not enough when it's, you're paying money. But this idea of seeking consent again and reconfirming intention, that's something that would be really interesting to study. And some jurisdictions are looking at mandated breaks in play, which have a similar function of reconfirming that, yes, I've thought about it and I've decided I do want to do this, as opposed to I just haven't considered it and my brain's been hijacked. And not to put a value on it. For some people, if they want to zone out and escape, fine. I'm not trying to put value-laden judgments on people, but more the fact that they've actually decided to do it. If you decide you want to gamble for 8 hours in a row, fine. But the problem is where people haven't decided that, it's somehow just occurred. It's something that's happened to them to a certain extent. I don't know what you, and Matt Tom's put a question up here around these of like, are there different types of people? And maybe it gets back to that sort of idea of, do you have something in your life that's attractive enough to go back to, or of a responsibility, or have you got something in your life that's bad enough you really don't want to go back to it? Is there anything about the individual differences to who is more likely to get into this kind of time suck of, repetitive behavior?
Yeah. Yeah, two things. Like, I think the first part to what you were saying about the enforcing breaks. There's in the social media world, there's an app, multiple, I guess, but there's one where they actually did a study. It's called OneSec. It does exactly what you're talking about. So you're after a certain time period, it pops up. No, before you open, like whatever you say, I don't want to use app, like say TikTok. Then the screen comes up and it says, do you really want to do this? And you have 5 seconds and you have to wait those 5 seconds. And they showed in the short term a reduction of, I think, 65% of app usage. Like, because people then think like, no, actually I didn't. I just out of habit went on that screen and clicked on that button. And then you're in that world without ever consciously making that decision because it's been habitual already. I don't know what the long-term data are because you can also develop a habit of waiting the 5 seconds. It's still effort. But the bigger you make the effort, the more people think about whether they actually want to engage with it. So any form of adding a little bit of friction is good when it comes to habits that are unfortunate habits. And we all know this. Like if you had to like people who want to quit smoking, if they had to walk to the store every time to get a cigarette, it's much harder, it's much less likely that they do it than if they have them at home and, you know, things are convenient. And I think here's the same thing. Make it a little less convenient to gamble for such a long period of time. And there's ways to cause friction that then allow you to do conscious decision making. Just, you know, get into a space where, as you say, you can still decide. But when you're in it, you're pinged by information, none of us is making a conscious decision to stay in it. Talking individual differences, it is absolutely fascinating because I think we sometimes think, oh, I'm not going to fall for an illusion. You know, when even with the stop buttons, people notice that maybe they don't do anything. But one of the things that we see is the impact that you see on outcome prediction is regardless of whether they use the stop button or not. So even if I don't even stop, the mere fact that the feature is there makes me believe technically I could control it.
Yeah.
So it really is about implicit beliefs. But even more fascinating, so they ran a study in the 70s, and I can't find the paper anymore, but it totally changed my belief about spurious attributions. So they did a task where they also wanted to manipulate your belief about control. So what they did is, oh, did I? I am here. So basically, they rewarded people, and they could press buttons on something whenever it would take them longer than 7 seconds. So at the beginning, you're in this room, you don't know what to do, and you know it takes you more than 7 seconds, you get a reward. And then you basically enter a certain key frequency or whatever you're doing, but you get faster and faster at it. So at some point, you no longer get rewarded. And people are like, oh, what did I change? And then they come up with all sorts of the weirdest reasons of why it's no longer working, that they no longer get rewarded. And they described one participant in this study who every time would stand up on the table, take off her shoe, touch the ceiling with her shoe, come back down, put the shoe back on, and it always takes longer than 7 seconds. So she would always be rewarded. It's an absolutely adaptive process. If she left the experiment, she would tell you what you had to do is like basically step on the table. And that's the perfect example of spurious attributions. I don't think any of us is protected from spurious attributions. Everybody does it all the time. We now do work on human credit assignment where we look at, can you design credit to things that have delayed consequences? Like, you know, we all know we like the chocolate now, but technically exercise has better long-term effects. Why are we not engaging in it? And we see people are terrible at learning delayed effects of actions. Very, very bad. And like that concerns us all. So I think it's just, we are in a space where learning whether we have control or not is hard. And it's hard for everyone. And yes, there are individual differences to the degree to which we may be subject to spurious attributions. But I don't think it is necessarily something that is just a trait aspect that you're born with. I think what's much more likely is that it's contextual. So in contexts where you understand a lot, it's much easier to distinguish between, did this just happen randomly or did this happen due to my own action? Yep. In places where, like, you know, experience helps you, knowledge helps you. So that's why in some contexts we can have completely false beliefs. And I would bet with you everybody has a completely false belief about some, like their diet, their, you know, things that impact them, something they're allergic to that they're probably not, you know, like all sorts of things that you can develop that belief about and still be a completely rational person in another context. So I think a lot of it is actually more contextual than trait, but that's my personal.
And that makes sense. And I think it also gets to the idea of the consumer shouldn't be the one responsible for having to do this. You know, we should make, you know, if someone wants to touch their shoe to the ceiling and that's fun for them and it makes it more enjoyable, that it's more, that's fine. Like, it should be okay for individuals to have irrational beliefs around a product and still engage in it with a safe way. And I think that's, you know, it's kind of beyond the conversation of the next level of then what do you do? And, you know, it's obviously for policymakers to think about not allowing products that have features that are deliberately misleading and lead to, you know, irrational behavior, which have harmful consequences. So again, it's not the behavior that's problematic. It's the consequences, you know, what is happening for that individual as a result of their behavior. And that differs. That's an individual difference. You know, what's affordable, what's the time, what, you know, what is happening for that. If they're paying penny slots for an hour and they spend just a small amount of money versus if they have really intensive gambling behavior, there's so many things there that we don't have time to get into. But I really want to thank you, Frederike. It's so interesting to hear about your work, and my mind is buzzing with all the questions that I still have, but I really appreciate you taking the time to explain it to people, and because there's so many things that you can do in this type of work that's not possible in real world modeling or real world context that we can learn from. What's the best way? And I know you've got so many different you know, we didn't talk about Brainstorm and many of your other projects, you know, your chronic pain interventions. So there's so much more to you than what we've discussed here. What's the best way? Is LinkedIn the best way for people to get in touch, or is there another website you'd like to direct people to? We can add it to the show notes as well.
Oh, LinkedIn is good. Yeah.
And you've got your own website as well, which will pop in the show notes.
Yes,
Look, we've just got another minute or so. I was wondering if there's anything you wanted to touch on that we haven't.
No, I agree with you. It was a wonderful conversation, very fun. I did not even realize that an hour went by.
Awesome. It's definitely the way to go. And again, a thank you to Khalil Flander and Brett Abarbanel for putting us in touch. Thank you so much, Frederike, Dr. Petzschner. It's been an absolute delight to have you here today, and looking forward to having another conversation down the track. And thank you to everyone for dialing in. Thank you for your questions. And please share this episode with anyone you might be interested in. A big thank you to the Brain and Mind Centre for supporting the webinar series, and particularly to Harrison Stein and TJ Santos for doing all the background behind the scenes work to make us function so well. Please join us next week, where we will be having our Early Career Researchers Showcase as our final episode of season 5. And if you have any comments around what you would like to see in season 6, please shoot me a message. I love hearing